Hello, Professor Jakovich here, and we're going to discuss how to solve for the present value of a single amount. Now, when we're solving for present value, that means we need to find out what is something that we're going to get later that we know about in the future. What is it worth in today's dollars right now? Shrinking out inflation, taxes, shrinking out all that stuff. So, the first problem is about our aunt, who says we can either wait until she's really old, about 25 years, she says, and then she'll give us $50,000, or she'll give us $1,000 today, and that's it. So we invest our money right now in the stock market, and we're earning about 15% on it. So we need to know, should we take the $1,000 and then we can do whatever we want with it? We'd invest and probably make 15% on it. Or should we wait 25 years and get $50,000? How do we set up a problem like this? Well, just as with my future value problem, I set up a table down here below. So our present value is what we're trying to solve for. We know that the $1,000 today is worth $1,000 right now in the present. We don't have to do anything with that to know what it's worth in today's dollars. But we do have to take that $50,000 and just completely go backwards and find out what is the equivalent amount of money in today's dollars versus 25 years from now. So we're solving for the present value of $50,000. So we're going to put a question mark in the PV because present value, we don't know what it is. It's what we're trying to solve for. We do know what the future value is. The future value is $50,000. At what rate should we use? Well, we know that we can earn 15% on our money. So that's actually the rate that we need to use in this problem. So 15% for rate or yield on investment. Number of periods is 25 years. So we put 25 there. Now this is a single amount of money. We're going to get that $50,000 25 years down the road, way out here to the right. And we're trying to solve is, I call this a bookend problem. We're trying to find out the present value and we know the amount way out here in the future, and nothing happens in between. So only with annuities, which we are not working with right here, do we put in a payment or type. So we just put zeros in there right now. Then we have everything we need to know to solve for present value. Now, cool thing about Excel is you just put equals and then what you're trying to solve for, PV, and then open parenthesis, and it tells you what to put in next. And it says rate. So I'm going to solve for, or I'm not solve for the rate, but enter the rate, which is 15%. Then a comma, no spaces, and number of periods pops up in bold. That's what's next. 25, comma, payment is 0, comma, future value, which shows in brackets, meaning it's optional in some problems, but not ours, because we do have a future value, and it is $50,000. Now notice I did not put a comma in my 50,000 because Excel would read that as 50 then, and then think that the 000 was type. So just 50,000, comma, and then my type is 0, put the 0, close parenthesis, and hit enter. The present value of $50,000 right now is $1,518.88. Now why is it negative? Because Excel says you have to give up something to get something. If I double click and we look at my equation, I put in a positive 50,000 that I'm going to get. in 25 years. What Excel says, what would you have to invest to get that 50,000 in 25 years? And so it thinks I have to give up that money. Well, so that's why it's negative. Don't worry about it. The equivalent amount of money is $1,518.88. So the $50,000 in today's dollars is worth just a little over $1,500 as compared to getting $1,000 today. So I could put $1,500 right here, a little over 1,500, wait 25 years, and it would be worth 50,000. If I put in 1,000, which is less than 1,500, it will not grow to 50,000. So I would pick waiting 25 years and get the 50,000. Now, of course, if you don't think you're going to live 25 years, or you don't trust your aunt to give you the 50,000, or you just are desperate for money, then go ahead and take the 1,000. But the 50,000 in 25 years is worth more than $1,000 today. So that's the first problem. Let's do the second one. We expect to graduate from college in 4 years, and you plan to get a new Porsche once you graduate. You figure that that Porsche will be about $150,000 to just buy it with cash at that time. You have some money put away earning 12%. How much do you need right now to ensure you'll have $150,000 at graduation? So you'll compare our result from this problem to what you actually have put away. And then you'll know if it will grow to 150,000 or more. So here we go. We're trying to solve for the present value of 150,000 that we need in 4 years. The future value is 150,000. The rate is 12%. The number of periods is 4 years. And again, payment and type are going to be 0. So, just as before, equals PV open parenthesis. And then I put in what Excel tells me to type in. So I'm just going to click on it. The rate is 12%. I clicked on it. I put a comma. Number of periods. I click on it. Put a comma. Payment. Click. Comma. Future value. Click. Comma. And type. Click and close parenthesis. Hit enter. Boom. Okay, 150,000. If I shrink that 150,000 right here at time 4, back 4 years, I would need at 12% to have $95,327.71 sitting in my account, earning 12% for it to grow to that much. If I don't have 95,000 saved up, it's not going to grow at 12% to 150,000. If I have more than that, like right now in the present, I actually have saved up 100,000, it'll grow to more. But I need 95,000 saved for it to be enough to buy that Porsche cash. Okay, and that is a couple of present value problems. I hope this helps.